Welcome to this explainer. Today, we're tackling a massive dilemma right at the heart of our global climate strategy. And we're going to explore a really fascinating new framework proposed to solve it. We hear about carbon reduction literally every single day, right? But there is a missing piece to this puzzle that's absolutely crucial for our survival. So, let's just dive right in. Now think about this for a second. Why does the Earth remain so hot even if we dramatically reduce our CO2 emissions? Imagine if we miraculously hit global net zero emissions tomorrow. Would the heat waves just stop? Would the oceans instantly cool down? The answer, unfortunately, is no way. There's a huge, glaring gap between reducing emissions and actually dropping the temperature we experience on the ground.
All right, let's get into Section 1, the thermal lag and the limits of carbon accounting. Right now, our primary economic tool for climate action is the carbon credit. It's a business system that trades the amount of CO2 reduced or absorbed as a financial credit. So things like renewable energy or forest conservation generate credits that companies buy. It makes logical sense, sure, but essentially it's really just carbon accounting. We're just balancing a ledger. It doesn't directly measure whether a city's actual temperature dropped.
So why aren't carbon credits enough on their own? Well, there are three big reasons. First off, global emissions just aren't dropping fast enough because of our growing energy demands. Second, and this is absolutely key, is something called thermal inertia. Our oceans and land masses act like giant thermal batteries. The heat that's already been absorbed by the Earth has a massive time lag. It doesn't just vanish into thin air when CO2 levels stabilize. And third, the real-world damage, the heat strokes, the droughts, the forest fires, all of that is caused by actual heat, not just a CO2 metric sitting on a spreadsheet somewhere.
There's a quote from our source material that just hits the nail on the head. It says, "The true goal of global warming countermeasures is not to adjust CO2 numbers, but to lower the heat accumulated on Earth. We really have to stop viewing this strictly as a concentration problem and start treating it as an accumulated heat problem."
Which brings us to Section 2, enter the cooling credit and directly cooling the planet.
If carbon credits measure carbon, what if we had a system that directly measured and rewarded cooling? This comparison brilliantly illustrates the paradigm shift we're talking about. On one side, you have carbon credits asking, did you reduce CO2? It's all about mitigation for the future. On the other side, cooling credits ask a much more immediate, pressing question. Did you lower the heat? This focuses on direct Earth cooling, tackling the thermal load that is literally baking our cities and oceans right now.
So what exactly is it? By definition, a cooling credit is a credit given to activities that measurably lower the heat load in specific environments. We're talking local neighborhoods, urban centers, agricultural soil, forests, or even marine ecosystems. It's about assigning real economic value to the act of directly relieving heat stress in our lived environments. Now we need to be really clear about what this isn't. Section 3, what it is not, and the geoengineering distinction. Our sources highlight a fascinating paper from Kobe University analyzing the intense ethical, legal, and social issues surrounding climate geoengineering. See, solar geoengineering, like injecting aerosols into the stratosphere to block sunlight, carries some profound risks. The paper points out a massive issue called the termination problem. Basically, if we start blocking the sun and then suddenly have to stop, global temperatures would violently and unpredictably spike.
An MIT tech review spells out just how extreme solar geoengineering is. We're talking about requiring highly specialized aircraft flying 20 kilometers up in the stratosphere. Initial deployment alone could cost $35 billion. Plus, it creates entirely unpredictable cascading effects on global weather. It might cool down one region while causing severe droughts in another. Furthermore, as the Kobe University paper notes, there are very real dual-use and military risks here. The ability to control the weather could so easily be weaponized.
So, to draw a really firm line between the two, solar geoengineering is a massive, high-risk global intervention aimed at blocking future incoming heat. Cooling credits, on the other hand, evaluate the reduction of existing heat loads locally, using safe, nature-based, and practical urban functions. It's not about dimming the sun, it's about healing the Earth's surface.
All right, moving on to Section 4, the power of water and rebuilding the Earth's cooling infrastructure. The starting point for these direct countermeasures is this incredibly simple truth. Water is not just a resource we drink or use for farming. It is actually the Earth's primary natural cooling medium. Where there is water, heat moves. Where there is no water, like in our concrete cities or degraded soils, heat just gets trapped. This all relies on the everyday science of evaporative cooling. It's pretty straightforward. First, water evaporates from soil or transpires from plant leaves. Second, as that water changes from a liquid to a gas, it physically absorbs the surrounding heat energy. And third, this naturally drops the local temperature. A forest isn't just a carbon sink, it's a giant, natural air conditioner. So what does this look like in the real world? What would a cooling credit actually fund? Well, we're talking about urban misting systems, even down to misting fans that use evaporation to actively cool city centers. Using water-retaining pavements instead of your standard asphalt. Organic farming that actually restores the soil's structure so it can hold water again. Green roofs, and even clever tech that applies micro-misting to lower the massive exhaust heat blasted out by our air conditioning units.
But since this is an economic credit, we have to be able to measure it, right? Cooling credits wouldn't just rely on a single carbon equivalent metric. They would use composite indicators. Things like actual drops in regional and surface temperatures, reductions in WBGT, which is a metric that measures human heat stress by factoring in humidity. It would measure the volume of water successfully returned to the local cycle. By proving a drop in temperature and managing exhaust heat, we directly prove a reduction in the energy demanded for artificial cooling.
This brings us to our final part, Section 5, an economy of cooling and monetizing survival. First things first, a massive, absolutely crucial caveat here. Cooling credits are not an excuse to emit CO2. Carbon offsets have faced a lot of totally valid criticism for basically becoming rights to pollute. Cooling credits operate on a completely separate value system. They aren't an offset for emissions, they are certified proof of a direct cooling contribution. Yes, we absolutely still must reduce carbon, but we also have to actively cool the heat that is already here.
Our sources make a really stark observation here. They say, since modern civilization runs on economics, we must incorporate the act of cooling the Earth into the economy. Altruism and warnings of a climate crisis, sadly, just aren't enough to mobilize the entire planet. Restoring water cycles and lowering urban temperatures has to become economically profitable for companies, cities, and farmers.
Which leaves us with one critical question to wrap up. Can humanity transition from an economy that merely balances carbon spreadsheets to one that actively and naturally reduces the heat threatening our survival? The concept of the cooling credit suggests we can, and honestly, perhaps we must. Thanks so much for joining me on this explainer. I really hope it gave you a fresh perspective on how we might actually cool down our planet.